The next speaker is Anne-Marie Charrett. The title is Knowing Your Oracles for When Requirements Are Not Enough. Go.
Thank you. Hello, everyone. Because I've been doing my Skype coaching now for a couple of years, one of the questions that often comes up is oracles. And it's been really challenging for me because I always thought I knew what an oracle was. And because I've had to help people understand it themselves, it's really challenged me to question it and really understand what an oracle is myself. So I want to share a bit of that today. Look, we're going to look a bit at the past. We know, pretty much all know that requirements fail us many, many times. I mean, we listened to Elizabeth today about the needs, intentions, and implementation, and how a requirements document we know, or acceptance tests or acceptance criteria, they're just not going to hack it. We know these things. We know that often they're not kept up to date. Things change rapidly. Often requirements don't actually exist in any written form or a specification that we can access. There are heaps of implicit assumptions being made in requirements, and there's no getting around that. And requirements are really one person's model of what the system, what the software is going to be. And because of all this is the real challenge for us. So when we test to these requirements, and we know these things as testers, we often find them lacking. So what do we do? How do we know when something is a bug? How do we find it if the requirements are not up to date or are not suitable enough? And what we use is our oracles. Now, an oracle is a principle or mechanism by which we recognize a problem, right? I mean, we as context-driven testers, most of us know this thing. We use people are sources of information for us. Our experiences are sources of information, and as well as existing products. Most of us are familiar with Michael Bolton's testing without a map and hiccups and the heuristics we can use to help us as oracles. And yet when I speak to testers online and I ask them what an oracle is, many, many testers tell me that it's a source of information. And so I really want to just tap on that today. That it's one of the misconceptions. Oracles are not only a source of information for us. They're a lot more than that. I mean, if you think of it like water putting out a fire. You know, yes, we use water to put out a fire, but that water itself doesn't put the fire out. If water's sitting in a bucket beside the fire, it's not going to do anything. It's only we apply it that it puts the fire out. And the same thing with oracles. Requirements on their own, people on their own, experience on their own are only sources of information. It's only when we apply them and evaluate and use our own personal judgment do they become oracles. Other fallacies are that oracles we can completely automate them. But in the essence of an oracle itself is that it needs a human. We need to be there. We're doing the evaluation. And it doesn't matter if we have an automated script that comes up with a green. We have to make, as a human, the decision whether that's actually a false positive or we're happy with that information. Or does that make us question the fact that it's gone green 100 times in a row, that there actually might be a problem? So really having a human and understanding what and evaluating our oracles are really important. So I want us to have a think about how we really need to understand. We really need to understand what our oracles are in testing. I feel that that we need to be able to apply them to add credibility to our bugs, right? So we need to be able to use them to say, this is a bug because I have compared it to an existing product, or I've spoken to somebody else, or I've used this. I know it's a bug because of this particular oracle that I've used, users' expectations and so on. Okay. We need to be good at also creating oracles. I think this is something that we suspect there's a problem there, and being able to create an oracle to actually recognize the problem. I think we need to start investigating how can we create little scripts to help us actually know whether a problem exists or not. And I think this is a real source of benefit for us as testers to start looking at, hey, perhaps I could actually create an oracle to help me see if there's a problem or not. So just to summarize, let's get really excited about oracles. Let's look into them a bit more. There's a wealth of information there, and happy to Skype me online on Charrett if you want any coaching on oracles. Thank you.
Oh, hello. Sorry to spring this on you, but just in case people out there, well, actually, I'll just remove that context from you real quick. You've been mentioning oracles, and you've been saying we should think about oracles. How would you define an oracle if you were asked to do it in, like, say, one sentence or maybe two?
Well, I see an oracle as a principle or mechanism to recognize a problem. It's the thing that we use to recognize a problem, to see whether a problem exists or not. So whatever that takes, I think a lot of people will use, yes, the requirements are one type of oracle, but there's also the product that you're testing itself, your own personal past experience and of using other products are oracles. Speaking to people and getting their opinion and in comparing that to what you know is another oracle. So there's lots and lots of different oracles out there that we can use. But I think the real challenge is to actually come up with your own oracles. I think that's where we can get really creative.
Another way of putting it for Curtis's benefit, and we're working on restructuring and defining this. We can also think of an oracle as a way of informing a decision, problem or no problem. It might be helpful to you.
So I like Michael's problem or no problem much better. Coming out of the embedded space, embedded software space, we've had oracles in that domain for years, and I'm referring to fairly complex programs or models that are essentially a analytic version of the embedded software. And if you're interested, I got some papers on this. We've found some problems, though. It's a good thing, and everybody should be working on it. But the problem you have to be aware of is what's known as the inversion programming problem that people have tried in the past in the programming world to improve fault tolerance and redundancy by having multiple versions of the program. And it's a good oracle. I'm not saying it's not. It's just there's some dangers that those people working with it have to be aware of because of the inversion programming problem.
Can you give us an example?
Sure. The classic example is when it's been studied that two teams of programmers creating version 1 and version 2 in about 10 to 30% of the programming effort make the exact same bug in the two independent programs. So in this case, it would be the oracle and the code, and those two errors essentially nullify each other, and you miss the problem. And it's been fairly well studied. There's more to talk about how to do that, but that's the nutshell of the problem.
No, thanks for that.
Well, if we can create a script, we can use an oracle to say problem or no problem, we can also create another script that might be able to say the opposite. So which one do we trust?
I think that's part of the inversion problem. But I think the suggestion, I'm not necessarily saying create a script to determine your oracle, but to create a script to help you recognize the problem. So one of the classic examples that I've seen is an automation script that helps to actually create PDFs that you can instantly compare images beside each other to do a blink test to determine whether that's a problem. So rather than if you manually went and physically snapshot every page, you wouldn't even think of doing that because the actual amount of time to take all those images would take way too long. But hey, if I create an automated script that will help me do a blink test to recognize the problem, that's a classic example of creating an oracle to help you see the problem.
And we're out of time. Thank you, Anne-Marie.